Hello guys, welcome to ACE Online and special welcome to SSC JE revision series for the subject Machine Design. Coming to myself, Hajaratwali Sheikh, and the faculty at ACE Engineering Academy. These are my few credentials. I secured 14th rank in GATE, 45th rank in ESC, and I've done my master's at IIT Bombay, and I'm having more than 12 years of teaching experience. So I can consider myself well qualified enough to guide you on SSCJE mission design subject, guys. In this video, we will discuss what is the typical syllabus and what is the weightage, and we'll see some of the model questions you can expect in the final exam, guys. Okay, without further delay, let's start the session. Now, if you observe carefully, guys, is live started? Now, a solid shaft can resist a bending moment of 3 kN and a twisting moment of 4 kN together. Then maximum torque that can be applied is, guys, I am giving 30 seconds of time. Please try to answer these questions, because questions from this topic is very frequent. I observed, guys, 3 to 4 times they given the question from equivalent bending moment and equivalent twisting moment. Please go through this. Try, guys. Okay. Now observe carefully, guys. Is it visible, audible now? Now observe carefully. See, he has given, guys, especially these formulas you have to remember, Amma. Whenever a shaft is subjected to bending moment and twisting moment T, then equivalent torque equal to formula, guys, square root of m square plus t square, and equivalent bending moment m equivalent equal to half of m plus square root of m square plus t square, half of m plus square root of m square plus t square. Okay. Now here observe, he's asking what exactly the maximum torque, which means that equivalent torque, guys, equal to square root of m square. M is what exactly? 3 square plus twisting moment, how much, guys? 4 square. The answer equal 9 plus 16, 25. The answer equal how much, guys? 5. So answer is option D, guys. Now, under torsion, brittle material generally fail. Tell me, guys, if it is subjected to torsion, guys, if it is a brittle material, if it is subjected to torsion, then it is going to fail at 45-degree plane. 45-degree plane, guys. I can write along the surface having a 45-degree with longitudinal axis. Option C is correct. Now, consider the following theories of failures. Maximum stress theory. There is no theory like that, maximum stress theory. Maximum strain theory. No. Maximum shear stress theory. Maximum energy or distortion theory. The most suitable for ductile material. Generally, guys, for ductile material, distortion energy theory is the most suitable, and maximum shear stress theory, guys, MSST. DET and MSST, guys. So I can write 3 and 4. So it is option D, guys. Clear? Next. For ductile materials, the most appropriate failure theory is, just now we discussed, guys, he hasn't given distortion energy theory. If they given distortion energy theory, I'm sorry, guys. First you have to choose distortion energy theory, guys. And then second one is maximum shear stress theory. Most appropriate one is shear strain energy theory, because another name for distortion energy theory is what exactly? Shear strain energy theory. If this is not given, then you can choose maximum shear stress theory, guys. Okay, next. For steel, the ultimate strength in shear as compared to ultimate strength in tension is, tell me, sir, for steel especially, the ultimate strength in shear, definitely, guys, shear strength is akin to maximum shear stress theory, 0.5 times of ultimate strength, which means that the ratio is half. Half means answer is option B, guys. Now, ties are loaded carrying members which carry. Tell me, sir, the basic definition of tie and strut. The moment you hear tie means it is under tension load, strut means it is under compression load, guys. Tie means what exactly, sir? Axial tension load, option C. Now, the stress concentration is is static loading is more serious in? Tell me, sir. The stress concentration static load. Generally, guys, for dynamic for ductile material, localization of each, this is not that much serious, guys. For brittle material, it is very, very dangerous if it is subjected to, guys, static loading. The answer is option B, guys. Next. Which of the following is not to be correct procedure to increase the fatigue limit? Please try to answer this question, guys. Which of the following is not to be correct procedure to increase the fatigue limit? Tell me. I want to increase the fatigue strength. Which one is not correct procedure? First, cold working, short pinning. This is the basic procedures to increase the fatigue strength. Under stressing also, the best procedure to increase the fatigue strength, guys. But surface decarburization is not the correct method. Why? Because surface decarburization means you reduce the carbon percentage. You reduce the carbon percentage on the surface. When you reduce the carbon percentage on the surface, guys, my strength, ultimate strength, even fatigue strength, all will be reduced. Whenever carbon percentage is reduced, guys, it becomes little soft. So all materials, all the strength will be reduced. But he is asking to increase the fatigue strength. So cold working, short pinning, under stressing is to increase, guys. This is to decrease. So answer is option C is the correct answer. Next. If the equivalent torque in the shaft is a very, very good question. If the equivalent torque in shaft is 500 Newton meter and the bending moment is, he has given T equivalent, guys. He has given T equivalent, how much he has given? 500 Newton meter. And the bending moment is how much he has given? 300 Newton meter. Then calculate the magnitude of the required torque and equivalent bending moment. Is asking T equal to how much to get this T equivalent and M equivalent equal to how much? Please try, guys. Please try this question. I'm giving 30 seconds of time. Please try, guys. Everyone, please try. Let us see who will give me the answer, guys. Guys, please try. Guys, observe carefully. Here has given T equivalent. I want to find out T. You know the formula, guys. T equivalent equal to how much? Square root of M square plus T square. That is given as how much? 500. But M is given as 300 whole square plus T square equal to 500. So T definitely should be how much, guys? 400. T equal to how much, guys? 400. T equal to 400. Okay, but 400 is there in the option B and option C. Now which one is the correct answer? I need to find out M equivalent. How can I find M equivalent, guys? I told you how to remember this formula, guys. M equivalent equal to half into M plus square root of M square plus T square. Now observe carefully. Half into M means how much, amma? 300 plus square root of M square plus T square, how much, guys? 500. Total 800 by 2. 800 by 2 means again 400. The answer is how much, guys? 400, 400. So it belongs to option B, guys. I hope this is clear for you. Very good. Now, maximum shear stress theory was postulated by, I must directly ask the names of the scientist who has given this theory. Maximum shear stress theory is given by, guys, exactly. It is also called Tresca theory or guest theory. Tresca theory or guest theory means, guys, maximum shear stress theory, guys. Next, which of the following is true for factor of safety? What is the basic definition of factor of safety, guys? Factor of safety equal to failure stress by working stress or permissible stress or allowable stress, guys. Generally, failure stress means what exactly here? Ultimate stress by permissible stress. Not tensile, not compressive, guys. It is the ultimate stress by permissible stress. It is belongs to option C is the correct one, guys. Next. A body is subjected to principal stresses at a point having values. He has given three principal stresses. Sigma 1 equal to 200. Sigma 2 equal to how much? 150. Sigma 3 equal to 100, guys. Then what is the value of maximum shear stress? This is a typical question from strength of material also, guys. Tau max equal to what the formula? Maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, comma, sigma 1 minus sigma 3 by 2. Now let us see, guys. Maximum of sigma 1 minus sigma 2 by 2. 200 minus 150 by 2. 50 by 2, it is a 25. Next, sigma 2 minus sigma 3. Again 50 by 2, guys. Again 25. Next, sigma 1 minus sigma 3. 200 minus 100, 100 by 2. Again 50. The answer equal how much, guys? 50 itself. So it is the option B is the maximum value of the shear stress. Next, this question already discussed, Amma. The equivalent, see, similar kind of questions they are repeating, guys. The equivalent bending moment for a shaft which is subject to the combination of twisting and bending moment is given by. It's asking equivalent bending moment, Amma. Whenever equivalent bending moment is given, it should be half of m plus square root of m square plus t square. Next, impact load is an example of, tell me, sir, in SSC 2020, guys. Impact load is an example of uniform load, static load, dynamic load, fatigue load, guys. Impact load means, guys, it coming in only once, guys. It changes with respect to time. It is called typical dynamic load, Amma. It is a typical dynamic load. Next, which of the following theories is the best applied to the brittle material? You're asking brittle material, guys. Brittle material means Rankine's theory. Rankine's means maximum principal stress theory, guys. So, what is the maximum principal stress theory? It is the option C, guys. Next, and with the option that completes the given statement with respect to the factor of safety. So, based on the factor of safety, 4 to 5 times they are given, Amma. I just mentioned 2 times to give the clarity. So, you can see, in 2020 to SSC, they given this question, guys. Ratio of working stress to ultimate stress. No, I just given the definition. Product, no. The moment you hear product, it should be wrong. Ratio of ultimate stress to working stress. Yes, the answer is option C is correct, guys. Okay, next. We'll see some of the questions from springs, guys. For a helical spring, spring index is typical spring index, guys. Okay, generally, spring index is capital D by small d. What is mean by capital D, guys? Assume if this is the spring and this is the capital D, mean diameter of the spring. Small d means wire diameter. This is the small d, guys, wire diameter. So I can write it should be ratio of, it is not difference, it should be ratio of mean coil diameter to wire diameter, sir. It is option C is the correct answer. Next. Leaf springs are subjected to. Tell me, what is the main purpose of leaf spring? Think about it. What is the main purpose? The purpose of the leaf springs is to carry the bending stress, resist the bending stress. Option A is the correct answer. Now, 2 springs of stiffnesses, K1 and K2, respectively are contained in series. Then what will be the stiffness of composite spring? Tell me, sir, here, springs are contained in series. You please try this question, guys. I'm giving 30 seconds of time. Please try this question, everyone. Please try. Please try, guys. Try to give me the answer for this. Here, springs are in series he has mentioned, Amma. So what should be the answer for this? Think. Guys, if you're online, please try to share your answers, guys. Oh, which channel it is? Yes, very good. Dev, please try among this question. What is the answer for this? Stiffness. Stiffness is series, guys. Series means 1 by k equivalent equal to 1 by k1 plus 1 by k2. So k equal to how much, guys? k1, k2 by k1 plus k2, guys. So k1, k2 by k1 plus k2 means it is the option A is the correct answer. Very good there. Now, yes, this question, guys, try this question. At least I hope you will be able to solve this question. It was the SSC 2017 question, guys. Please try this one. Please try, guys. Please try, guys. I hope you can able to answer this question, guys. See here, you have to remember the stiffness formula for the helical spring, guys. That is, the spring stiffness equal to K equal to GD power 4 by 8D cube into N, guys. N is the number of coils, G is the rigidity modulus, guys. Small d is the wire diameter and capital D is the coil diameter. Now if you see the question, guys, axial load under quantities remaining same, if the wire diameter is doubled, so D become 2D, guys, and mean radius of the coil also double. When mean radius is doubled, guys, your diameter also will be doubled, then stiffness of the spring when compared to the original one will be, stiffness of the spring when compared to the original spring will be, tell me, sir, K equal to, he has given, guys, G proportional I can write 2D power 4 by 2D whole cube, guys. If you observe carefully here, I am going to get K equal to, I can write approximately, sir, 2 power 4 by 2 means 2 into K previous I can write. So it is just 2 times sum, it become twice. So answer is option A is the correct answer. Very good, Dev. Your answer is correct. Now we will see some of the questions from riveted, bolt and welded joints. Yes. Let us see who will give the answer for this, guys. Think about it. A riveted joint may fail due to. A riveted joint may fail due to. One paper on table. Rough paper or any paper. Think about this, guys. Riveted joints will fail due to. Basically, guys, think about this one. See here, the questions from this one is very easy. Multiple times they given amma. Generally, guys, there are 3 types of failures will be there. Suppose assume this is the plate, this is the rivet, guys. Now, in this case, when the load is applied, who will fail, amma? Plate will fail, guys, because plate is weaker. Suppose in the rivet and the plate, if the plate is weaker, when the load is applied, what happened, amma? Plate will tear. Plate will tear, guys. That is the shearing of the plate. Shearing of the plate, sorry, guys. Shearing of the plate at the edge. same shearing of the plate at the edge, guys. Second thing is, guys, suppose if rivet is stronger, then what happens exactly? When the load is applied, rivet will be sheared. When the load is applied, what happens, guys? If the rivet is weaker, rivet will be sheared. Shearing of the rivet. Next, when both are equally strong, when the plate is weaker, plate will tear. When the rivet is weaker, rivet will shear. When both are having this equal strength, approximately equal strength. And what happened, guys? When I apply the load, what plate says that, array rivet, I will shear you. What rivet says that, array plate, I will tear you, guys. The both will form a crushing. Both will crush each other. It forms a crushing failure. So here definitely, guys, so it can be any three things, but he hasn't given any condition, guys, which one is weaker, which one is stronger, he hasn't given. So it can fail any of these three, guys. Okay, it can be shearing of the rivet, it can be tearing, it can be crushing, guys. Okay, I hope you got the clarity. Next, yes, please go through this question. The distance between centers of the rivet in adjoining rows of a jigsaw riveted joint is known as. To listen to our class, we have clearly explained this one. Please try, guys. Distance between centers of the rivets in adjacent rows of the jigsaw riveted joint is known as a diagonal pitch, guys. Known as diagonal pitch. See, observe carefully, sir. Zigzag. Then this is called diagonal pitch, guys, and this is called back pitch. Okay, and this is called pitch of, guys, pitch of the riveted joint, I can say. This is the diagonal pitch, guys. Please go through it. Now, same thing, similar kind, see, you can see, guys, similar kind of question given in turn 17 and turn 8 also given the same question, guys. The type of failures involved in the analysis of riveted joints are shear failure of the rivet, tensile failure of the plate, crushing of the plate. Then which one of the following statements are correct for the analysis of the riveted joints, guys? All three we have to consider. All three we have to consider, guys. Very good, Dev. You are giving the answers correctly. Really appreciate you. Now, yes, this one, guys. Try exactly it is. What exactly it is, guys? A cylindrical rod threaded at both the ends is called. A cylindrical rod is there, which is threaded at both the ends is called. Tell me, guys. Think about it. Think about it. It is called, excellent, excellent, guys. It is called stud. It is called stud, guys. Excellent. Next, the shearing strength of the rivet is 50. Yes, let us see who will give me the answer for this one, guys. Shearing strength of the rivet is 50 megapascal. If the diameter of the rivet is doubled, then shear strength will be how much? Think about it. Beautiful question. So far, whatever the questions I have seen, guys, this is the beautiful question I have seen, guys. Please try this question. High chance of committing a mistake here if you don't know the basics. Please try, guys. I would try to give the answer for this. Yes, the answer is what? Earlier it was 50, now diameter is increased. The answer is what, guys? It is again 50 itself. But the question is again, why? Simple logic, guys. The strength is a material property. It won't depend upon the size, shape, anything, guys. As given shear strength of the rivet. So it is a typical material property, sir. So definitely, guys, whether it's a big rivet or small rivet, my shear strength will be same itself. The answer is 50 megapascal. Clear? Very good. Very good, guys. Very good. Dev, excellent, Amma. Next. Yes, please try, guys. This question can be answered with the help of a engineering mechanics fundamentals also. This question, please try. Efficiency of a self-locking screw. Or you can ask, guys, efficiency of a self-locking machine. You might have seen the screw jack also, guys. Self-locking screw jack. What is the efficiency? Or to make the machine reversible and irreversible, guys. Screw jack must be irreversible. By self-locking, guys, if the load is removed, it will be remains at the same location. It won't go back to the original position. Reverse means exactly if the load is removed, guys, it will go back to the original position. Tell me, sir, what it should be? The efficiency of a self-locking screw is, think about it. Think about it. The answer is, always remember, guys, whenever efficiency is greater than 50%, it is called reversible machine or reversible screw. If it is less than 50%, it is called self-locking. Self-locking screw. The answer is what exactly? Should be less than 50%, guys. Should be less than 50%. Then, yes, please try this. Please try, guys. Everyone. The pitch value in the specification of TR means trapezoidal bolt, guys. TR means trapezoidal. 40 into 4 in bracket P7 of the multiple slot trapezoidal thread is. What is the pitch he is asking in this specification, guys? Whenever he mentioned P7, P10, whenever it's a P7 means pitch is 7. P10 means pitch is 10, guys. The answer is 7 mm. So option C is the correct answer, guys. Very good. Now some of the questions from bearings. Which of the following is a typical disadvantage of the roller contact bearings? Sir, roller contact bearings are anti-frictional bearings. Friction is very, very less with the help of roller contact bearings. Then, what is the basic disadvantage, guys? See, so tell me what is the basic disadvantage, guys? The basic disadvantage is high initial cost. Because to make the rollers very, very smooth, having a very high surface finish, guys, the manufacturing process is very, very difficult. So it makes the contact bearings are high initial cost. There for 14 you can go to the thread specification, you can understand. But whenever he mentioned P7 or P8, so this is belongs to pitch, guys. This is belongs to pitch. Okay. Now coming to next one. Which of the following is anti-frictional bearing? Tell me, guys. Which of the following is anti-frictional bearings? Which of the following is anti-frictional bearings? Think about it. See, guys, pedestal bearings, collar bearings, hydrostatic bearings, these are called frictional bearings. Frictional bearings. A needle bearing is the anti-frictional bearing, guys. The type of roller bearing itself, needle bearing is the anti-frictional bearing. A question on this one, they given 3 to 4 times, guys. Okay, next. So you can see, guys, in 14, in 19 also they given gamma. In 19 also they give the same question. So dash is a type of anti-frictional bearing. Without second thought, needle bearing, guys. The questions are giving multiple times over here. Next. The most suitable bearing for carrying very heavy loads with slow speeds is having heavy loads with slow speeds, with less speeds. Tell me, sir, what is the most suitable bearing for this? Think about it. Try, guys. It should carry heavy loads and less speeds. Less speeds. Think about it, guys. It should be having a heavy loads but low speeds, guys. What exactly? It is called what type of bearing, Amma? Generally, guys, for low loads and low speed, we use ball bearings, but here, heavy loads with slow speeds, guys, we use hydrostatic bearing. Hydrostatic bearing, guys. Generally, low loads, high speeds, we use the hydrodynamic bearing, Amma. But heavy loads, slow speeds, we use hydrostatic bearing, guys. Now, anti-frictional bearings are, you please go through this one, guys. Yes, this is a very much tricky questions. Let us see who will give the answer, guys. The questions are anti-friction bearing given 2017. Please try, guys. Anti-frictional bearings are. Think about it. Anti-frictional bearings are. Think about it, guys. Guys, when I'm looking at side means I'm watching your answers, guys. In the screen they have provided, okay? Think. Anti-frictional bearings are what type of bearings, guys? Here, what is the answer for this? Sleeve bearings, hydrodynamic bearings, thin lubricate bearings, ball and roller bearings. What is the answer here? A, B, C, D. Which one is the correct answer, guys? Think about it. Guys, think. Think about it. Guys, these are called, whether it is a sleeve bearing, whether it is a hydrodynamic bearing, whether it is a lubricant bearing, thin lubricant bearing, guys. These are called friction bearing itself. Only ball and roller bearings are anti-frictional bearings, guys. But nothing is given. Only one wrong. Only 2 and 3 wrong. Only 3 wrong, guys. Should be answer 4. Answer 4 is not there in the options. So none of these is the correct answer, guys. Clear, everyone? Next. In hydrostatic bearings, 1 second, guys, the pressure to lubricant is supplied by. So in case of hydrostatic bearing, who will supply the pressure to the lubricant? Think about it. It is due to external force, Amma. Some external source is required to supply the pressure to the lubricant, guys. In case of hydrodynamic bearing, guys, exactly, it form a thick film due to the friction. The friction will provide the sufficient thickness, guys, in case of hydrodynamic loading. But here, external source is required to give the pressure to the lubricant, guys. Okay? Now, while transmitting power through a shaft, dash is used to hold and support the shaft, guys. While transmitting power through a shaft, dash is used to hold and support the shaft, guys. Bearing, gears, belt, pulley. Tell me, sir, it is bearings, gear, belt and pulley, nothing but a bearings itself, guys. Now, please go this question. The power transmitted to a shaft of diameter d, rotating at a speed of n rpm, the power P is related to diameter d and n as. Please, you know, guys, this formula. P equal to formula is 2 pi nt by 60. But you know that, guys. N means rpm, T means the torque. In case of shaft, how can I find this torque, guys? You know, shear stress tau equal to 16T by pi d cube. Assume this is a shear strength. Then T equal how much, guys? Tau into pi d cube by 16. The answer equal how much, guys? 2 pi n tau into pi d cube by 16. So P proportional to how much, guys? N into d cube. N into d cube means, guys, it is matching with the option A. Very good, Dev. Your answers are correct, Amma. Next. The shear stress at the outer surface of a solid shaft with diameter d and torque t is how much, guys? Direct formula, guys, 16t by pi d cube, guys. If it is bending moment, m is there, 32 m by pi d cube, guys. Okay. I hope you got the basic clarity, guys, about what type of questions they are asking. If you need any further guidance, further support, please contact us. Okay, and we are having a exclusive SSC JEE classes are there. If you would like to join, you can join for further guidance, guys. And finally, I would like to say, on 26th May, you are having a mega mock test. But the fee is very nominal, guys. You can ask the question, sir, why you are keeping the fee? Guys, if it is free of cost, students are not taking that much interest. Students are not serious, guys. That's why we are taking very nominal fee. One pizza cost around 150 rupees, guys. Less than the pizza cost, guys. We are giving a very good quality mock test. This is very helpful for you to assess your knowledge, guys. So please, without further delay, try to register for this mega mock test, which is in the online mode itself for civil, mechanical, and electrical. If you're having any friends from civil and electrical also, please inform them and ask them to read this test, guys. It is very, very helpful. I hope you understood well, guys. With this, I'm stopping the session. And thank you, Dev. Really, you are giving the answers. I think almost all your answers are correct. I haven't seen any wrong answer. I wish you all the best. I hope you will crack the exam. Okay? Thank you, guys. If you're having any questions, guys. Dev, I think definitely inform you about your feedback. Yes, your race is correct. Short theory sessions are very helpful. Okay. Inform to the management about this, your suggestion. If it is possible, we will plan it immediately, guys. Okay. I will inform about this one. Okay. Okay, guys, with this, I'm stopping this session. Wish you all the best. Thank you.